Yep. All right, so the box that you're looking at, we gave it the name, the Hydro Duster. And you'll see why in the slide.
Ready?
Alright, well, the problem is TG Kentucky was where we tested this at. And they have a braiding room over there. And there's a lot like dust and stuff where they have to make the rubber, or they flatten out rubber. It's like dust, I guess, to keep it kind of dry, or not dry, but keep it from
It's basically a lubricant to slip over the braided on the brake lines. They're dealing with brake lines is what it is.
and then dust where they make it inside a separate room inside the TG on the rubber side. And dust is everywhere in there. If you go inside, you can pretty much tell as soon as you walk in, the floor is really slick and everything. And dust is, I help my dad's Neil Lamb, and I work in refrigeration. And we just replaced new HVAC units on top. And they're just pretty much destroyed from all the dust that's just clogged up the condenser coils and everything, and they're really expensive to repair. So we thought of something that would try to help this problem. It's not really, really expensive.
And easy to maintain. All this is a full of water that it sucks down into. The Hydro Duster. It's a box equipped with an intake duct. This fan sucks air into the box. This box is held with water. Whenever the fan starts going, the water actually starts to spool, and that collects the dust and doesn't allow it to get out. Your clean air blows out this way. So basically you're sucking air in this way, it's spooling it in the water, which is capturing it and blowing it out this way. And we have tested this and it seems to work. Surprisingly,
So far, it's pretty good.
it's worked. All right, these are the isometric views. This is the blueprints of what made this. We took this and drew it in an audio desk file, which is in the classroom. Spent about probably a little over a week drawing this, putting all the finishing touches and dimensions on it. And that way we could take it to our fabricator and give him a blueprint or something that he could go off of rather than estimating and roughing it. We did take some time on making this. That's the Hydro Duster as a drawing. That is in the file that I'm talking to you about, the Revit file, audio desk. Basically, it's a 3D view, and that was our blueprints. Took the blueprints. And we got
On the right side up there is the intake. The long piece right there where it comes in is where the fan sits, and the water comes probably about 1.5 inches, 2 inches up above it, to where it kind of, when the air blows down after it goes for a while, it kind of just like blows the water like that, and opens up, and it just sucks the dust back into it and traps it, and then lets the new air out this side right here.
And like we were saying, this is your blowout, which would be right here. This is your intake, which is right here. There's the water box, it's self-explanatory. You got your water in, which is these valves on the back of it, which are either one you want. This would be your drain valve, but you can fill it with either one. There's 3 of them, and there's only 2 of them in our drawing because whenever we were testing it, we got to realizing whenever you drain it, the dust wants to stay at the bottom. So if you put another inlet in there and you hook a water hose, it actually flushes it. So you can clean it a lot easier that way.
Doesn't build up in the bottom.
All right, so you're scratching your head and you're like, what the heck does this thing do? Here's you an idea. It goes, the water in, which is the outlet on the back, fills the box. The fan intake sucks in the debris, which is dust. The debris is trapped in the water, and then the air pressure that is in the box from sucking in is let out to your blowout intake. And then the dirty water is trapped in, clean air let out.
Alright, so this wire is just a regular, 100, you can just plug up the regular wire, 110 volts. And, it's all made out of 18 gauge galvanized metal, all this, and, pretty much.
The intake fan is the brains behind the whole thing, and it was probably the most costly thing that we had to get. It was donated by Land Refrigeration. It was, like you said, you can do it 110. That's what we're running off of right now, and so far it works really well. This is what is actually pulling the dust into the box. Without this, there's no opening. The water box is 18 by 18. It's galvanized steel, 18 gauge. When we got to looking at it, we were actually wanting to go a little thicker on the top, just because whenever you put the welding on it, it would kind of want it to warp the metal. So on our next one, we want to go a little thicker on the top box. But everything else seems working.
Alright, the metal, it was Boone Sheet Metal in Springfield, Kentucky, downtown. I think they're back behind, wherever the other plays at and stuff over there. They're back near them.
Behind the Opera House.
Behind the Opera House, there
There
you
you
go.
go.
And they got the metal in, they ordered the fan for us, and they welded everything up and we put it together. So they're willing to work with us on that, and I think they want to kind of help us get it going too.
Which this box is stainless steel, not to mention, and that's its own art of welding. So it wasn't nothing that your average Joe could do by any means, and they did an exceptional job on it.
Like I said, the test site's in TG, Kentucky. Here's some pictures right here. If you can really, really see, like, I know it's hard to see, but like right here is like it's like just like a piece of glass kind of that's overlooking where the braided comes out. If you can really get up close and see it, you can see it on the board. I think they're on there. You can't really see into it. It should be clear, but it's really, really dusty. Like you can see on here at the top right here, it was just in there not for that long, and it was covered in dust, and we got it back. And
This is the mirror that he's talking about. He just slid his finger over there and there's a bunch of dust. Like when you walk in this room, like it feels slick, like it's clean and polished. It's dust on the floor. It's pretty bad.
Yeah, I know my allergies have been acting up a lot since I've been in there.
Our survey results. This one was really hard to get survey results on it because I couldn't hand half of this room right here a survey and say, do you think this product will work? Because half of you don't have any idea what this product actually does, and with good reason. You're not in the field of dust and you don't have that problem. So to get a bunch of surveys, or the ones that we did get, we had to send these emails to like actual refrigeration companies. So we had 12 in favor of it, and the ones that weren't in favor of it were people that were working at factories that already had a system going on. Now, it wasn't anything like ours, it was high scale, but
So instead of doing that, we asked Brian Posh, he's kind of the head of the braiding room, to just write just send us an email that proves that he wants to use it or looks forward to using it and letting us test. So we figured that might kind of help out since we couldn't get very many surveys. All right, y'all got any questions? Yes.
How did you conceive this idea? I mean, where did the idea come from?
Well, like I said, I helped my dad, and we were working at TG over the summer, and we all noticed that, gosh, this is a bunch of dust, and it's got to be really expensive to repair. And I think it's like $12,000 a unit. It's pretty expensive. You got to replace more than one, maybe every year or something. It gets pretty expensive. So we thought, well, let's try to come up with something that's not, they don't gotta spend a lot of money on a dust collector. It's like $50,000, something that's a lot cheaper that can do the same thing.
But was this idea conceived to use in like a small area rather than a whole building?
Right now, it's kind of just a smaller area, not
Okay.
huge, but we're
This
working
is-
on getting bigger.
This is the prototype. Now, when we tested it, we realized, they're gonna need a big one,
A
bigger,
or
or
more.
maybe more. But with the repair cost being $12,000, they're willing to do what they need.
Have you ever thought about making a design for residential usage?
Yeah, oh yeah. Like, even in our PowerPoints, you could use this residential. It
But
would
we
probably
want
be-
to try to make something that looks a little better, because I mean, that's for industrial use.
Okay.
You don't gotta look too pretty. but-
Well, you have this on a cart there. Would it be stationary where it's set?
It would be
We
mounted.
we just moved in because it's kind of long walking up and packing.
You gotta think, there would be water lines running to this to
Yeah.
flush it
You
in,
hook-
flush
You
it
hook
out.
the water line up to it to where it stays in it, and eventually it'll be set up to where it automatically flushes on a timer every so often.
I got one more question. I know somebody's got some other questions too. You said the intake is, that it comes down below the water. This is the water level.
Mhm.
The intake comes down below the water level, is that
Mhm.
correct?
Yeah,
And the water level is about how far from the top?
about 2 inches.
Well,
Okay.
see that, or like it sits down probably about, this goes all the way down to probably about right
Oh,
there.
okay.
And then it sits up just maybe that much over it. Just kind of, and once it starts sucking, it kind of just pushes it out to where it kind of bubbles up. Looks like a hot tub kind
When it
of.
blows the air back out, does that have tendency to blow water with it or just?
Right now, that's why we have this. We didn't really realize it till we tested it, but that's why that's there. It kind of stops it from just,
Okay.
it doesn't, it's not much, but it's enough to, kind of see. But right now, that's enough just to stop it. But we plan on going further with it.
How often do you envision having to clean it?
Over there, as of right now, it's pretty often. Probably, right now, at least every day. It's pretty bad.
If the idea is to circulate the water through the thing, is there a reason why you went with a square box as opposed to like a cylinder?
Not really haven't.
It's a good
Honestly, I
idea.
haven't really thought about it.
The square was, it was easier to make. Like I said, you're dealing with stainless steel, and bending it to a sphere would be a whole lot more expensive. And how they would mount it, I have no idea. With the square, you could put it on a bracket, you could put it on a brace, you could put it on a cart. You don't have to worry about it tipping over.
But even in its current shape, it seems to accomplish the task you want to actually
Right,
collect the
right.
dust.
So far,
Yeah.
You would be able to modify some sort of cylindrical tank.
Or even if you
And
could
make
put
it
it on
work.
the inside of the square, that'd be a good idea.
But another thing we've noticed is, like, of course, with it sucking right here, obviously this is gonna be, the fan itself is gonna be really dirty. So we're thinking about trying, the next time we test it, we might flip it over to where it's sucking from inside and then actually pulling through this side and pulling back out, kind of like,
Will they pull the water with it?
that's what we need to find out. I don't think it will, but it might. But see, this side, it doesn't come all the way down in.
You need another semester for that, right?
Yeah.
Just a few quick questions. Any impact to the humidity in the room with the water and the fan going across and the aerator?
It's only been in the room probably less than 24 hours.
Yeah, probably right at 24 hours.
Yeah, probably less. We had to build this thing, get a presentation, board together.
So yeah, we're kind of slacking a little bit. I should have tested longer.
It's a lot to do. It's a
But
whole lot to
if you're
do.
looking to do this in potential other areas residential, humidity control for air conditioning is a big impact.
It's gonna be a big thing, yeah.
Second thing, in this case, the dust was not combustible, but you need to be considering your fan, if your contacts are sealed and you're bringing dust into that, it will combust.
I got you. I know what you're saying.
That's what we're trying to
So what kind of cost has gone into this, or can you estimate that?
Right now, it's probably, I'm not sure, it's kind of, I mean, it's expensive, but not, I guess it's expensive for us. It's probably, we're probably looking at maybe 3,000 or 4,000 because it's pretty expensive, but it's expensive to make because,
You gotta think of all the time and labor that went into it.
Just kind of guessing here, not that you would know this yet, but if you've worked with your dad in the heating and air, compared to the normal kind of projects that they would install for an industrial place, not so much a residence, but any kind of business. And the cost of materials seem to be in line with those projects, or a little bit more, a little bit less.
I mean, everything with it is expensive, and just like the materials is what's expensive. I mean, the fan itself is pretty expensive.
I know I heard Neil talking, they actually wanted TG to quote them like a $50,000-$60,000 system. With this, you're way under budget, and it's gonna, because you gotta take into consideration, they're gonna have to run lines all the way through the building, out to the building, all the duct, everything. With this, it's on a cart, you can roll it around where you need it. It's a whole lot less. Yeah.
I guess you'd have to do calculations on the capacity, the size room it would clean.
Right.
Yes.
What's the estimated capacity of that test device?
Right now, we set it in probably a room about half of this size in the area of which,
It's a lot bigger.
and when we drained this, it was completely gray water, like it was pretty bad. So,
And how long did you have it running that day?
It's probably
less than-
18 or
yeah.
19 hours.
wasn't very long at all.
But it sounds to me like it needs to be cleaned every day, minimum.
Oh, yeah.
Yeah, maybe,
Which
maybe
is why
more than
we're
once a day.
putting in
That's
here.
why it's gonna be set up automatically to where they don't have, the TG doesn't have to worry about someone coming in and changing it, like they always gotta change the filters and everything. It's gonna automatically do it.
That answers the first question, which is how is it superior to a fiberglass filter? Next question, I don't know if Nathan's thought about it or not, but depending on what kind of environment that this thing is in, and it's collecting all these particles out of the air, are you just gonna flush it into the sewers or any of that, some other kind
Well,
of environmental impact?
I know I talked to Brian Tosh yesterday, we talked to him about it, and he said they'll have to test the water before they can flush it to make sure that there's nothing that will contaminate outside or the ground or anything. They're gonna test it, and send off a test if they decide to go with it and use it.
So if you can't come up with a sewer system, and this might be for your next semester, if you can't come up with a sewer system, what kind of containment vessel, device, location, are you gonna take the debris that comes out of it?
I need to figure that out.
It's an environmental issue now.
Yeah, so that's what,
In
It's
the
like
interest
running
of
a gas
time, if
station.
we don't have any more, we've gotta keep moving, so.
I have one more question. So how clean was the room? What was the difference? Was it very noticeable with that unit in the room versus what it was before you put it in the room?
it's so bad, you'd have to clean the whole room
To know
to
how
know
big of an
how
impact
big
you
of an
had?
impact it would have.
So really, the only thing
You
you
come
know
back to that
is how
anytime you
much
like.
is in the water.
We
It'd be
didn't
a while,
walk in
'cause
there.
I mean, I know they put the new braiding machines in because they expanded, and within the next day, I was just we were in there, and I just wiped my finger across, and my hand was covered in dust, and that was just within 1 or 2 days. So it's pretty thick.